Welcome, everyone. Training a great machine learning model is only half the journey. The real test is ensuring that model functions reliably in the real world. Today, we are diving deep into the MLOps outer loop, focusing specifically on how to expertly test and troubleshoot machine learning model endpoints in production environments. Let's begin by defining what a model endpoint actually is. In the world of machine learning operations, or MLOps, a model endpoint is a managed REST API. It acts as the secure bridge between your data science environment and your production software applications. The basics involve two deployment types: real-time online endpoints for instant, single-record predictions, and batch endpoints for processing millions of rows asynchronously. Why do we need them? Because a web application cannot run a Jupyter notebook. It needs a fast, reliable API to communicate with. How do we create one? We package the model, the environment dependencies, and a scoring script, and Azure deploys this as a scalable container. For our deep dive, if you use MFlow to register your models, you can utilize no-code deployment. The platform automatically generates the scoring script and deployment configuration, eliminating massive amounts of boilerplate code and potential errors. Take a look at this high-level architecture diagram. On the far left, your client web app sends a JSON request containing fresh data over the internet. This request hits our managed online endpoint, which acts as a secure traffic router. The endpoint routes the request into our active deployment container, where the scoring script executes the data against the trained model. Finally, the generated prediction flows right back to the client as a JSON response. Our job today is to ensure this entire flow is bulletproof. To test endpoints safely, we must understand the MLOps outer loop. What is it? The outer loop encompasses the packaging, deployment, testing, and monitoring of your model. The basics require us to completely separate the inner loop where data scientists experiment from this highly governed release phase. Why is this separation mandatory? Because pushing an experimental, untested model directly to your customers is a recipe for disaster. How do we manage this safely? We utilize multiple environments. First, we deploy the model to a staging environment. This is a safe sandbox where we run our endpoint tests. Only after the model passes quality assurance do we promote it to production. Diving deeper, this architecture enables advanced routing strategies like blue/green deployments. You can deploy a new model alongside the old one, route just 10% of your user traffic to the new endpoint to test it in the real world, and only switch over completely once stability is proven. This flow outlines a mature MLOps deployment pipeline. We pull our model from the registry and immediately deploy to the staging environment. The system hits the daemon node, run automated endpoint tests. If the endpoint fails, perhaps due to a missing library, the pipeline routes to investigate and retrain, protecting our users. If it passes, it moves to a human approval gate. Once the business stakeholder approves, the pipeline automatically deploys the verified model to the production environment, moving seamlessly into continuous monitoring. Now, let's talk about the mechanics of testing. What does testing a deployed model mean? It means sending simulated, structured payloads to your live endpoint to verify it processes the data correctly. The basics involve using standard REST API tools like curl, Postman, or the Python SDK to send this data. Why is this critical right after deployment? Because while your model might have trained perfectly, the deployment container might be missing a Python package, or the scoring script might be expecting a different JSON schema. How do we test it? We construct a JSON payload with known sample data, send a post request to the endpoint URI, and verify we receive an HTTP 200 success code containing our prediction. For a deep dive, understand that a senior engineer doesn't just test happy path data. You must send malformed JSON, missing fields, and extreme edge cases. Your scoring script must catch these errors and return clean error messages, rather than completely crashing the container. This sequence diagram shows the precise, secure testing handshake. Our automated test script first requests a bearer token from Azure Enter ID, ensuring our endpoint is secure. Armed with the token, it sends a post request containing the JSON payload. The online endpoint receives this, validates the token, and forwards the payload into the scoring container. The container runs the math and returns the result, and our test script happily receives the HTTP 200 response with the predicted value. When a test fails, how do you fix it? You need observability, and we achieve that using Application Insights. What is it? Application Insights is an Azure Monitor feature that provides deep performance management and logging for your applications. The basics are that it silently collects metrics, console logs, and network telemetry from your endpoints in real time. Why is this non-negotiable? Because if your endpoint suddenly returns an HTTP 500 internal server error, staring at the screen won't help you. You need to see exactly what exception was thrown inside the container. How do you implement this? You simply toggle the Application Insights flag when configuring your endpoint deployment. For our deep dive, the true power lies in Kusto Query Language, or KQL. Instead of scrolling through thousands of lines of raw text, you can write a targeted KQL query to instantly isolate requests that took longer than 2 seconds, or filter specifically for out-of-memory exceptions, turning hours of debugging into minutes. Look at how telemetry flows into insights. A failing endpoint request occurs on the left. The error data is instantly ingested by Application Insights. The platform categorizes this telemetry. Perhaps it's a high-latency metric, an out-of-memory log, or an exception from missing Python package. We then use KQL query analysis to filter and cross-reference this data, rapidly converging on the exact root cause of the failure so the engineering team can push a fix. For complex models, especially generative AI or multi-step retrieval systems, simple logs aren't enough. We need advanced tracing. What is tracing? It is a diagnostic technique that captures the step-by-step execution flow of your application. The basics rely on two concepts: spans, which represent individual operations, and attributes, which hold metadata like timestamps. Why is tracing revolutionary? If you have an AI agent that searches a database, processes the data, and generates a response, and it takes 30 seconds to run, standard logs won't tell you which step caused the delay. Tracing does. How do we build it? We use OpenTelemetry to wrap our Python functions in trace spans. Diving deeper, this creates a visual hierarchy in Azure. You can look at the top-level session span and drill down into the business logic span, and finally into the model call span. If your JSON parsing function is failing, the specific span will turn red, giving you immediate, surgical precision when debugging. This tree diagram visualizes a trace hierarchy. The root is the complete user request trace. Notice how it branches into distinct spans: data pre-processing and business logic. The business logic further breaks down into an external API call and a generative model call. By selecting the model call span, we can view its specific attributes, such as a duration of 1.2 seconds and a token count of 450. If this span fails, we know immediately that the model call is the culprit, not the pre-processing step. To operate at an enterprise level, we must automate our troubleshooting and testing. We do this using GitHub Actions. What does this mean? It means using CI/CD pipelines to automatically trigger endpoint tests the moment a deployment finishes. The basics: your workflow deploys the model to staging, immediately fires a Python test script at the endpoint, and records the result. Why do we enforce this? Because humans are fallible. Manual testing is often skipped when teams are rushed. Automation provides an unbreakable quality gate. How is it built? You write a YAML workflow that securely logs into Azure and executes your test suite. If the tests fail, the build fails. For our deep dive, we combine this automation with human-gated approvals. The pipeline runs the tests in staging and then intentionally pauses. It alerts a senior engineer who reviews the Application Insights telemetry. Only when they physically click Approve does the workflow deploy the model to production. This sequence illustrates our automated CI/CD pipeline. When code is merged into the GitHub repository, it triggers GitHub Actions. The action first deploys the model to the staging endpoint and immediately executes the automated tests. Once staging confirms the tests passed with an HTTP 200, the pipeline pauses, waiting for human approval. Upon sign-off, the pipeline safely and automatically deploys the verified model to the production endpoint. Troubleshooting doesn't end once the deployment is successful. We must implement continuous monitoring. What is this? It's the ongoing, automated observation of your endpoint's inputs and outputs. The basics involve detecting data drift where the data coming in looks totally different from your training data and concept drift. Why is this vital? Because unlike standard software, ML models degrade over time as the world changes around them. An endpoint that is perfectly accurate today might be dangerously wrong in 6 months. How do we solve this? Azure Machine Learning automatically collects the live endpoint payloads and compares their statistical distribution to the baseline training data. Let's deep dive into self-healing architectures. You can configure custom alert thresholds. If data drift exceeds 15%, Azure Monitor automatically fires a webhook directly to your GitHub Actions. This triggers an automated pipeline to pull the newest data, retrain the model, and deploy a fresh, accurate version without manual intervention. Here is the life cycle of continuous monitoring. The live endpoint continuously sends its daily payloads into the model monitor. The monitor compares this live data against the baseline training data. It hits a decision point. Is drift detected? If the statistical drift is below our threshold, it simply continues monitoring. But if drift exceeds 15%, it takes the critical path, triggering an Azure alert, which directly calls a GitHub action to retrain the model, closing the MLOps loop completely. Let's tie all of this together with a real-world scenario from Prosware. Prosware is a healthcare startup that deployed a critical diabetes classification model to a real-time endpoint, accessed by doctors through a web app. The challenge: the web app development team updated their JSON data schema without warning. The model endpoint failed silently, returning skewed, inaccurate predictions. This is a massive risk in healthcare. The action: the MLOps engineer completely revamped the deployment architecture. They introduced GitHub Actions to deploy to staging first and enabled deep application insights tracing on the endpoints. The outcome was immediate. The next time a schema update occurred, the automated test scripts intentionally failed the staging deployment, preventing a production outage. For the deep dive, the developers didn't have to guess what broke. They opened the trace spans and application insights and pinpointed the exact line of Python code where the JSON parsing failed. They patched the scoring script, approved the pipeline, and rolled out the update with zero downtime. In our final diagram, we see the Prosware rescue flow. A web app schema change triggers the GitHub action to deploy to staging. The automated tests run and intentionally fail. The engineers immediately jump to App Insights trace analysis, rapidly identifying the parsing error. They fix the scoring script, run the tests again, and upon passing, the system securely deploys the healthy model to the prod endpoint. Testing and troubleshooting transformed from a crisis into a routine, automated process.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.